Hi guys, I received this question from one of my friends. They asked me to do this question for them. This question is about IDMT relays. Then I went out and kind of picked up some old notes so that she could understand. So IDMTs are relays that are used in transmission lines, power systems, networks. So they are used to actually detect overcurrent and on the network and interrupt by triggering a circuit breaker on the network. Actually, IDMT stands for inverse definite minimum time overcurrent relay. So it's actually interrupting high currents at a very small time. Yes. So the IDMT relays consist of characteristic curves, which are normal inverse characteristic curve. It contains its own tripping time formula. So its tripping time formula is TC equal to 3 over log M. So TC stands for tripping time, the M stands for multiples of setting time. And we have also the vary inverse characteristic curve. It has its own formula of TC is equal to 1.6 divided by log M all squared. So the M still stands for multiples of setting current, and TC still stands for current tripping time. There's also a extremely inverse characteristics curve. So it also has, the only difference is to the power 3 on the denominator. So now, these are the old types of relays, and they had the disk. So the relay itself, it had a disk that travels with respect to time relative to the current that it wants to interrupt. So now that adjustment of the disk is traveled by is named as TMS relay. So TMS, how to calculate TMS, you can either use this formula, which is TA equals to TC times TMS. Then you can make TMS the subject of the formula if you have TA. TA is the actual tripping time. So if you set your relay into a certain tripping time, then that tripping time that you've set is TA in terms of this formula. So we know TC is the tripping time of the relay. So there's a difference between the tripping time and the actual tripping time. So the tripping time is when it starts to, the disk starts to travel, and the actual tripping time is when the relay is actually tripping. So TC on here, so it's that operating time where the disk starts to travel. They explain it here. Okay, so TMS is a time multiplier setting. And we also have, you see the formula has containing the M, which is, I said, is the multiples of setting current. It also contains its own formula, which is its own formula is equal to is M equals to I sec divided by IN times plug setting. Okay, so plug settings normally on the questions is given in terms of percentages. Yeah, sometimes the I normal current, this is the current on the secondary side of the current transformer. This might be 1 depending, or either 5 depending on the type of the current transformer you are having. And then, okay, so it gave me this question. So this question is saying that a relay must trip in 0.7 seconds for a fault current of 10 kiloamps at a point of relay application in a network. So a 5 amps relay with a plug setting of 100% is to be used, and a CT ratio of 800:5 is chosen if a normal inverse IDMT relay is used, a normal inverse IDMT. So for this, we already know which IDMT that is using normal inverse, meaning that we will need this formula for a tripping time, which is now the formula for a tripping time. It's going to be TC equals to 3/log m. Right, that's the formula that you're going to use for the tripping time. Okay, now what else are we given? We are given the ratio. Let's just put a comma in there. We'll put the CT ratio is 800:5. Okay, so we have that. So for us to be able to get to the point where we calculate the tripping time, we need to first calculate the things that are around the tripping time. Okay, so now what we don't have is the multiples of setting current, which is M. So for us, the formula to calculate the multiple tripping time, tripping settings of current is M equals to I secondary divided by IN times flag setting. Okay, so for us, we have that, but at fault, we know that on a normal operating network, we have secondary current as 5 amps, which is also displays on the ratio. We have 5 amps, and then we have 800 on the normal operating conditions, which means now IN will be equals to 5. But now we want the secondary current at fault conditions. So now, meaning that now we have the fault condition as 10 kilo amps. So we want a respective current on the secondary side corresponding to the fault current. So now for us to do that, we need to know how to calculate the secondary current. But we know that the formula for a current transformer is equals to N. We can say in this case either to differentiate between the normal and the abnormal, we can just put N for the ratio and 2/N1. Okay, so now these are at this ratio. The ratio now is instead of N2, we're gonna put 5. Instead of N1, we're gonna put 8. Then we do have the primary current as 10 kilo amps. So now what we're going to do is I sec equals to I prime times N2/N1. So this is 10,000 times 5 all divided by 800, right? 800. So pass that to the calculator. Okay, then we get once we pass that to the calculator, then we get 62.5 amps. So this is the current on the secondary side of the current transformer. So now this is that current. Okay, this is that current. So to give a clear picture of this thing now, is to do this. Let me just give you a clear picture where the relay is actually placed. So let's take it for example. This is the line, which is the cable that is carrying the fault current. So now we have now the current transformer. Okay, so it's moving like this. So this is the I primary. okay, and this is the I secondary. So the relay is sitting on the secondary side. The relay is sitting on the secondary side of the current transformer. So this current that flows here is now at fault current is now 62.5. That's the fault current that will cause the relay to trip, because the relay is set to such that only 5 amps is flowing on the secondary side. Okay, now let's go and calculate the multiples of setting time, which is M. Let's go calculate M. And then if we put M here, let's say put M is equal to I sec IN times plug setting. Plug set. Okay, I'm not gonna finish that. So we know the plug setting there it was given as 100%. So this is plug setting. Okay, so to convert that percentage to a normal value, you can always divide by 100. You want to get 1, so that is going to be now 1. So we have our fault current as 62.5 divided by our normal current. As I say, IN is our normal operating current, so it's going to be 5 times 1. So now what are we going to have? Using the calculator, we're going to have 12.5 of M is 12.5. So now it's the time that we can calculate the tripping time of this relay. So the tripping time of this relay now is going to be defined by the formula here, by this formula here. Okay, so now let's take that formula and put it down. TC is equal to 3 over log M. Okay, so we know 3 is divided by log. We know M, which is going to be 12.5, then is equal to, so put that in the calculator, plug it in, then you get the time. The time will be now, after, it's going to be 2.735 time. Operating time, we calculated that is 2.735, and then we have TA equals to the actual tripping time we're given as 0.7 seconds. So now what we don't have is this TMS. So to calculate the TMS, to fully get the settings of this relay, that will be to rearrange this formula. It's just going to be a TA divided by TC. Then it will be TC will be 2.735 divided by 0.75. Then you get your TMS. TMS, if you pass the calculator there, it's going to be 0.256. Okay. So this is less than the full disk travel, but yeah, now you have your relay settings calculated, you have everything done. So now they wanted the TMS of the relay, so this is the TMS of the relay, and then now the question is answered. You have to keep in mind which relay are you dealing with. Is it a normal inverse relay? Is it a very inverse relay? Is it an extremely inverse relay? Okay, you need to calculate the actual tripping time if it's not given. But if the actual tripping time is given, like this question is 0.7, then you don't need to calculate it. You need to calculate the tripping time, which is TC. So if you calculate the tripping time of the relay, then you calculate the second calculations will be multiples of setting current, so which is M. You calculate M. Then if you're done calculating M, now you calculate you go ahead and calculate TMS. So once you get the TMS, now you have answered the question. Now you can say you have calculated all the settings